We're going to do another example in graphing a quadratic in vertex form. Number 3 is y equals 1/2 x minus 2 quantity squared plus 4. I'm going to rewrite underneath the vertex form again. As you can see, we have x minus 2, x minus h, that means 2 is h, plus k, plus 4, and that means k is 4. Therefore, my vertex is going to be 2, 4. So even though that this says x minus 2, you think of that as a negative 2, but the format is x minus h. So therefore, h is actually a positive 2. In order to graph this, we're going to put this into our table in the middle, 2, 4, and we're going to surround the x's by decreasing by 1 and then increasing by 1 for a total of 5 points. We want that vertex to be the center point in order to make the graph symmetrical, easier to see the curve. So to find the y values, simply plug in your x values. First one is 0, y equals 1/2 times 0 minus 2 squared plus 4. Order of operations, parentheses first, that's going to be 0 minus 2, negative 2 quantity squared. Exponents are next. So do not multiply 1/2 times negative 2. You've got to do negative 2 squared first. This goes first. So 1/2 times 4, because negative 2 squared is 4. Then do multiplication. 2 plus 4. 1/2 times 4 is 2. And y equals 6. Let's repeat it again for the x value of 1. So y equals 1/2 times 1 minus 2 squared plus 4. So y equals 1/2 times 1 minus 2 is negative 1 squared plus 4. So that's going to be 1/2 times 1, because negative 1 squared is 1, positive. 1/2 times 1 is 1/2. And 4 plus 1/2 is 4.5. Exactly. Now, if this were a decimal that were not exact, I would like you to keep it as a improper fraction. So your y value is 4.5. Now, as I showed before, it's going to be symmetrical. So 4 is going to have a y value of 6, and 3 is going to have a y value of 4.5. So graphing these 5 points, 0, 6, that's up here. 1, 4.5, that's halfway in between 4 and 5. 2, 4. 3, 4.5, so back halfway up to 4.5, sorry, between 4 and 5. And lastly, 4, 6. Compared to the first parabola we graphed, that quadratic function, this one looks a little wider. And I'll pan out so you can see the difference. See, this green one up here is kind of narrower, and this one's a little bit more wider. That's due to the a value being 1/2. Like we said before, if the a value is between 0 and 1, it kind of flattens the curve. We call it vertical compression. So to describe the transformations. Transformations here. Where did it move? How did it move? Well, the vertex is 2, 4. That means it moved right 2 and up 4. The a value is 1/2, so therefore is vertically compressed. And it was not reflected. A is positive, so you don't have to write anything for that. And those are your transformations. Domain, range, and zeros. Domain. It goes left and right forever, negative infinity to positive infinity. Your range, lowest and highest point. Lowest point here actually bottoms out on the graph at 4. And this continues to move upwards forever, both sides of the parabola. So it's going to go on to positive infinity. And zeros, the x-axis. The x-axis is all the way down here. And at the lowest y value, the range is 4, that means it never gets to the x-axis. Therefore, there are no x-intercepts or zeros, so you can write no zeros. Either or is fine. Because it never crosses it. It's got all this gap in here, in between the x-axis and the actual curve itself. So this is the graph of the vertex form of this quadratic. Identify your h, k, make your table, calculate your y values, graph your points, state the transformations, state domain, range, and zeros, and that should be it. Number 4, you're going to do the exact same thing as before. I do want you to notice this though. When I rewrite the vertex form underneath this one, h and k we found just as before, x minus h, x minus 3, plus k, plus 1. So we know that the vertex is 3, 1. Now, look at the a value though. A is negative 1. So for transformations, this is actually going to flip downwards. So before it pointed up like a U, now it's going to point down like a hill. Okay? In making your table, put 3, 1 in the middle, fill in your x values. You calculate your y values the same as before. I'm going to fill those in though to save time on this video. See how that mirror image still? So once you calculate this, it should come up like that, repeating themselves, the y values, to keep that U shape. Graphing this, 1, negative 3, 2, negative 1, one correction to make here, these y values are not negative 1. They're actually 0. Let me fix that. Apologize. So this should really be at 2, 0 here. I'll erase that point on the graph. Three, 1, 4, 0, and 5, negative 3. And you see when your a value is a negative 1, or any negative number, it actually flips it the other way, reflects it. So in your answers here, for transformations, it moved right 3, up 1, and it has been reflected down. So those are your 3 transformations. Domain and range and zeros. Domain, again, it goes left and right continuously forever, so negative infinity to positive infinity. Range. Now the lowest point here, there is no lowest point. It starts at negative infinity. It continues down forever. But it does top out here on the graph at positive 1. So your range is from negative infinity to positive 1. Your zeros, there are 2 of them. I'm going to highlight them in blue. These 2 zeros are where the function crosses the x-axis. So that's at x equals 2 and x equals 4. And those are exact because they're points that I plotted on the actual graph. So the negative a value made the function flip downward.